So that's some background about effect size, and once we run this run results today, we'll get the effect size, and we'll talk a little bit more about it. And so post hocs. So post hocs, how many of you are familiar with post hocs or heard about post hocs? Okay, some of you. Okay, yeah, so when I see post hocs, it makes me think about post docs. Very similar. And I think as when I first learned about what is it, like post hoc, ad hoc, it's weird. So in terms of post hoc, what it means, it's afterwards. So last week or Monday we talked about when we do ANOVA, we get an F value, and the F value is an omnibus test. It's a test of the overall significance. So it tells us, is there significance in this overall ANOVA test? But if there's more than two groups, so if there's PhD, PsyD, and NFT, we have three groups. We know there is group difference, but we don't know which group is different from which. And of course, if we're doing a study, we would want to know, are PhDs different than PsyDs, or are PsyDs different than MFTs, or are PhDs different than MFTs on a certain outcome variable. So we'll have different comparisons. So in that example of three groups, how many pairs of comparisons would we have? PsyD, PhD, and MFT. Okay, 1, 2, 3, 4, 5. Okay, 3. We would have 3. So we would compare pairs. So we would compare PhDs and PsyDs, right? PhDs and MFTs, PsyDs and MFTs. So we have 3 pairs of comparisons. So we're making more comparisons than just 2. So if it's 2 groups, we only have 1 comparison, group 1, group 2. So we're making comparisons. And why is it so important when we're making more comparisons to do post hocs? So there's 2 reasons. One, we want to know which group is different from which. We want to know specifically, like, is PhD and PsyD, how do they compare on this outcome variable? So that's one. And the other one is because of the error. So as we said, the first thing we look at when we get a result is look at the p-value, right? And the p-value is important because it's an indicator of the error, like likely chance of committing an error. And so we often set it to 5%. So we don't want to make more than 5% chance of error in terms of predicting our results or rejecting our null hypothesis. So that's important. And so when we do more tests, there's more likelihood of making errors. So for example, do one test, we control the error to be less than 5%. So that means we have more than 95% confidence of getting it right if we reject it. But if we do 2 tests, if we want to get both right, it would be 95% times 95%. Then we would have only around 90% chance of getting both of them right. So this kind of probability stats, we would multiply them to get the overall chance. And if we're doing 3 comparisons, like the PhD, PsyD, and MFTs, then it's 95% times 95% times 95%. So we end up with around 86% chance of getting all 3 correct. So in other words, there's 14% chance of getting something wrong there. If we want to control that 14 to under 5%, we would have to adjust the alpha level, the level of error that we're willing to tolerate. So as we see here, roughly family-wise error is the number of tests times the alpha level. So like here we have 3 tests, alpha level is 0.05, this is 0.14, but it's roughly close to 0.15. So it's similar to 3 times 0.05. So family-wise error would get larger as we do more number of tests. And so if we want to control the overall level of error, what would be a way to do that? We could adjust or lower the alpha level. So rather than doing 0.05, we could do 0.05 divided by 3. So that would be 0.017. And then that would, when you times it by 3, it'll be around 0.05. So doing the 3 comparisons will control the error, likelihood of making an error to still be around 5%. Does that make sense? Okay. So there's different types of post hoc tests. There's 2 big groups. One is planned comparisons, and one is post hoc or follow-up comparisons. So planned comparisons means that you plan ahead before you run the study, when you're designing the study, what kind of groups are you going to compare? So for example, I have PhDs, MFTs, and PsyDs, and ahead of time, I'm just interested in the difference between PhDs and PsyDs and PhDs and MFTs. I'm not interested in PhDs and PsyDs and MFTs, for example. So I know which one I'm going to compare against and which ones I'm not. So that's already planned. You can't do it afterwards, like, oh, it seems like there might be difference between PsyDs and MFTs, so I'm going to do it now. So planned comparisons is something you do ahead of time when you're designing the study. And there's 3 types of planned comparison adjustments, post hoc. It's weird, this is post hoc, this is planned, but they're all post hocs. And so like three different kinds. So one is Bonferroni. So Bonferroni, have you heard of that term before? Okay. In regression? Oh, okay. Okay, so Bonferroni is the most easiest way to do post hoc adjustments. So it's just dividing the alpha level by the number of tests you're doing. So for example, we said if the alpha level is 5%, 0.05, and we're doing 3 comparisons, we just divide 0.05 by 3. If we're doing 5 comparisons, divide 0.05 by 5, then we reach a 0.01 alpha level. So Bonferroni is the most simple one, but it's the most conservative one. In other words, if you use Bonferroni, it's less likely for you to get significant results compared to other kinds of adjustment. And there's Welch's correction, and that's for non-equal variances. And then there's Dunnett's correction, and which is when you're comparing one single control group with multiple treatments. So, so I think, so I was talking about Dunnett's. So the issue with Dunnett's is that when the design is set up that you have one control group with multiple treatments, then we do Dunnett's. So for example, if we have a control group, we have a CBT, a psychodynamic, and a humanistic. That's a situation where we can use Dunnett, and we just indicate that this is the control group, and we're just interested in comparing the treatment groups against the control groups. We're not interested in comparing between CBT and psychodynamic, etc. And Tukey is a post hoc test, which you can explore after you've designed the study. So it's it's like, oh, there is an overall significance. Okay, let me dig into which one is different from which. And Tukey is the one that has more power, and Scheffé is the one that's a little bit more conservative. So it would be harder to reach or get a significant p-value with Scheffé. Okay, so that's basically that's the different types and what categories they belong in.